Okay, the recording have started. So let's start our webinar, and we're recording a bit. First of all, as you know, my name is Nikita. I'm a course instructor, so I will provide you any possible help from my side. And my main goal is to make your experience with this course as fruitful as it possible. Of course, to be honest, you will face some difficulties, especially of technical character on the course. First of all, we have some troubles with expression handling. So sometimes you will face a problem like you are sure that your answer is correct, and your answer is correct, but there is no such answer. It means that the system doesn't accept your answer because, for example, if you want to, yes, we will talk about indeterminate forms. That's not a problem. So I just will finish one idea. First of all, we can talk about the. I want to say that sometimes you will face such problem as you have seen in the chat. I hope all of you know that we have a chat in Telegram. So sometimes what you can have an answer like square root of e, but you can have some ideas how to write it. The system can accept one of these variants. So unfortunately, I have no possibility to write to write a special character like hat. So it's not an easy task. Okay, like that doesn't make sense. That doesn't make sense. Like the system can accept something like with one. It looks terrible, I understand, but maybe you understand. The system can accept something like with one. The system can accept something like with one. So, so sometimes it's possible that you have an answer and it's correct, but the system doesn't accept it. So in this case, I ask you to communicate with Azamat, our course assistant, who will be always ready to help you. Okay, so you will face some technical difficulties when you will pass the course, but please contact us. We'll try to solve the problem as soon as possible. Okay. Yes, both of these. There is no. Unfortunately, we try to cover all the answers in every possible forms. So, but sometimes there are still uncovered forms. Like we try to handle all the expressions. Like all of these answers are correct. We try to figure it out in this way. But sometimes we can miss some forms of the answer. Okay, so as I see, we have one of the most interesting things to discuss is to discuss types of indeterminate forms. So, to be honest, usually on practice nobody talks on practice. I want to repeat it again, but nobody talks about some specific forms of indeterminate forms. Like nobody handle expressions like here I see an infinity over infinity, so it makes sense. But it's something like more natural, intuitive knowledge, I think. But as you know, but we call in simple words. I think we will start with simple words, not with specific and formal descriptions. Indeterminate form is in any form of expression such that you can't easily say an answer value of the limit. For example, as you know, if you have something like 1 plus, I don't know, 1 over n, just for example, that's not an indeterminate form. It's a complicated word so much, and my pronunciation isn't brilliant, but I hope you have no blood from the ears. Like here, you can easily say that there is no trouble here, there is no problem, because it's easy to see that this expression tends to 1, with to 0, with to infinity. So we have something like 1 over infinity, and the answer is no, is 0, and answer is 0. So that's an easy thing. It's an easy thing to discuss. But unfortunately, sometimes we can face such expressions that you can't easily say the common value of limit. For example, one of the most famous thing is this one. As you can, I think that you know that its the name of this expression is second significant limit. In Russian, it's always called второй замечательный предел. I hope that the majority of students of the course understand in Russian, and I think it will be useful just to know these words, how it sounds in Russian. Okay, and for example, you know that E is a Euler's constant, is a value of this expression, like the value of this limit if E tends to infinity. Okay, as you can see, for example, why do we have an indeterminate form here? Because if we will avoid some specific mathematics that gives us an answer of this expression, always how to say it, sequence, the limit of this sequence, when one can see that this expression tends to 1. I think it's nice, it's easy. So, and don't forget that you always can stop me, you can ask me. I will be really pleased to see your cameras turned on, because it's a bit complicated to talk with black boxes, especially with muted microphone. So like you're the only guy in the desert and you're waiting for a miracle. Okay, but it's not a problem if you don't want to turn on your cameras and microphones. But you can easily see that this expression tends to 1, this expression tends to infinity. In a common case, you can't say you can say nothing about the value of such expression. So first of all, is it a simple idea? Do you understand why we can't say tends to infinity? Sorry, incorrect symbol. Why we can't say the proper value of this limit? Can you give some ideas of expression of the form of 1 in the power of infinity, so that we get different values, not like E? Do you have any ideas? That's not a big problem. I'm really interested in communication, like any possible form of communication. Written questions, pronounced questions, pronounced commentaries, and so comments. So I just want you to communicate with me, because that's an idea of webinar communication between the lecturer and students. I ask you for if you know any examples of expressions of sequences, so that we have the form of 1 in the power of infinity, and maybe you can provide several examples with different limits. For example, one sequence with 1 limit, another example with another limit, and so on. Like we have at least one example of sequence with 1 in the power of infinity, such that whole the expression tends to E. Maybe you can suggest any idea, any variants, any forms of this, any sequences of this form, so that it tends to 1, or so that it tends to infinity, or maybe that it tends to square root of E. Like I want to see different sequences of this form with different values of the limit, not like E. Maybe you can provide any examples or some examples. So Yes, for example, that's a good example. Like, and as I see low activity in chat, so if you understand what I'm talking about, please write plus in chat or plus minus if you. Yes, I agree. You are correct. Yes, please write plus in the chat if you understand what I'm talking about, or minus if you don't understand, totally don't understand, or plus minus or minus plus if it's like so like you are not sure but you understand what I'm talking about, or partially understand. At least I want to estimate an amount of students who want to participate actively. Okay. Yes, you're quite right. Artyom suggests us some good examples. For example, we can take the limit of the following form. 1 second, please. Limit of such expression below. We can try to compute this limit. What does it give to us? As you know, it's a common idea in the whole mathematics that you try to solve every new task using your knowledge about the previous one task. For example, here we can see that this task is really close to with basic knowledge. You know that if you see something like with, it reminds us something like with a second significant limit. Okay? I hope we're okay. So, so I will be really glad to see pluses, minuses, and such things. So it gives me a thing that you believe me, that you understand what I'm talking about. So it's nice. Thank you for the participation. Like here we can see that, for example, this expression tends to. I hope that there is no arithmetic trouble, and you understand that why this expression is the same as this expression, like n in square in the power is like n in power of n and the power of n. So I hope that's a clear thing. Okay. So, and what can we say about this expression? We have a common knowledge that this expression, for example, tends to e. We know that it tends to e. And this thing tends to infinity. So somehow one can write that we have something like e in the power of infinity. And it's easy to see that the value of this expression will be infinity. So using the same technique, as Artyom provided us, we can say that having a for example, or having a 1/2 of n, for example, we can say that value of our limit, like for example, will be square root of e, and so on. So as you can see, both the situations, this one and this one, formally gives us an indeterminate form. Because we know here one can see that this expression tends to 1 and this to infinity. So formally it gives us indeterminacy. But using some knowledge about the indeterminate forms of this type, like this the most classic form of some most classic example of indeterminacy of the form 1 in power of infinity. No, I think that you know it because you faced it in the course. Yeah. So usually you can the majority of limits of this type 1 in the power of infinity can be solved using your knowledge about several second significant limit. So of course we have different types of indeterminacy. I'm not sure that I'm ready to write all of them, especially because, as I understand, you see the examples in your course. So I'm not sure what you really need me to repeat it again. But I hope that at least, oh my god, I hope that at least we discussed that how the common idea that what's the doubt of indeterminate form. So it's some form of expression that you that needs a special analysis to get a concrete value of the limit. So for example, we have something of form, if you have something like e in power infinity, it always tends to infinity. If you have something of the form 1 in power of infinity, it can have a limit like e, or like infinity, or like square root of e, or something else. So that's the basic idea. Do you have any specific questions, any other questions about the indeterminate form? Maybe I'm not sure that I got your questions. So it was kind of wide one. So maybe you can help me and offer something or specify your question. Okay, dear students, do you have any other questions? Any question about the material of the first week, or maybe of the second one? I don't know. Do you have anything you want to discuss? So nice. I will be glad to hear it. I will be glad to read it. So just show me. Just give it to me. How type questions in open questions. So look, okay, it's technical question, but of course it's this question is fair enough. Unfortunately, we have no useful possibility to write it here, like to provide a good to provide here a good mathematical expression. But as I remember, I opened a possibility to relay links or to relay or writings or to relate images. So, for example, I suggest you. Unfortunately, there is no convenient way to add mathematical expressions here, or maybe at least I see it's like a bit disgusting, like a bit complicated structure. Formally, you can use this reductor, as you can see. You have reductor or formula reductor, and but it will be really it won't be a convenient thing to use it. But if you know tech language, maybe if you know what does it mean, maybe if you want, I suggest you first of all to understand how to work with it. But you can use yes, it's possible to use tech, of course, text formally, but you know, I suggest you to made an acquaintance with text notation, and for example, how to write convenient and beautiful expressions even in this system. Or the most simple way is to relay links, or to relay maybe relay. Also, why relay? So sorry, it's a tipper in my head. You can place here links or images. So or maybe relay is relay is a good word. You can relay images here or links with your handwritten notes, or maybe text notes. I don't know. Have I answered your question, Elvira?
Well, can you hear me?
Yes, I think it's okay.
Okay. I think that it will be easy to say. I don't have the same button as you know, for the formulas. I just checked it right now. Mine is quite limited.
So you have
Oh,
just only
okay.
this part of the
Give me one
panel.
sec.
Yes? Oh.
Oh yeah, now I see. Thank you. Okay, yeah.
Okay.
Now you have answered. Thanks.
Of course, I'm glad to hear it. So, any other questions about the material of the first week?
Can I ask another quite stupid question?
I like stupid questions, so of course, you're always
Okay.
welcome. Yes.
So look, I quite don't understand why we study limits separately for functions and for sequences or series. Isn't it the same, no? Because in the second book we will have limits for functions.
Look, first of all, there is very significant difference. Yes, we have difference. Of course, in the sense of idea, like, but formally we have the same idea behind the limits and behind the limits of functions and limits of sequences. But like, we have some thing, function or sequence, it tends somehow somewhere, and it will have values close to something, and we want to find this something. But formally, the main difference is that function and sequence are totally different structures, totally different things. Like, first of all, because sequence is the most simple thing, is a much more simple thing, because it's, first of all, it's discrete. That means that we have some easy to count amount of points, like first one, second one, third one, and so on. Of course, it can be where we can use infinitely many numbers, but all of them are discrete, we're separated one from each other. And as you understand, function doesn't work this way. Like, you can't, if you know the second, the following term of, you can easily find the following element of sequence, but you can't find the following point where you can compute the function. So, because in some doubt, function isn't discrete structure. It's not a discrete structure. So, also you can find some interesting examples. Maybe I will use some books I like to use when I talk about mathematical analysis. So, I hope that the majority of students knows Russian, but we don't need to know Russian even. We just need to know just mathematical notation. For example, I want to discuss something with you, but when you talk about the sequences, the most significant technically thing is that your argument n always tends to infinity. There is no way, like, it's a one road. You have one road to 10. Like, you start with 1, 2, 3, 4, 5, and you go to infinity. But it doesn't work this way when you talk about the functions. For example, let's compare two limits, 2.4 and 2.5. What's the difference between them? What can you say? Well, one can see that we have, like, unfortunately, we have the same expression. Okay, no, another question, like 2.1 and 2.4. Look at them. 2.1 and 2.4. As you can see, we have the same expression under the limit, just the same symbols, the same functions, blah blah blah. Everything is the same. But what's the difference between this thing and this limit and this limit? What can you say? Sorry for bad quality, but you know.
So the only difference is that in 2.1 the x is tends to minus infinity and 2.4 it's plus infinity, yes?
Yes, of course. So, as you can see, we have one more power, well, one more space of freedom. Yes, when you talk about functions, because it's really important to understand what's the point of the limit. What's the limit of your argument? Like here, it's minus infinity, and here is plus infinity. It influences the expression significantly. For example, what can you say about the limit of this expression? What's the limit? First of all, let's start with 2.4. What's the limit of this expression? First of all, please write before the answer. Please write plus minus or plus minus if you understand what to do here. So if this if this limit looks like simple one for you, and minus like it's unsolvable for you. Plus minus if you think that you know what to do, and so on. But you are not totally sure, but you have an idea what to do. So the more statistics I have, the better I can provide learners. So I am always glad to see pluses, minuses, and other symbols. Okay, let's discuss it. As I understand it, you can. Yes, for example, we can do it. We can do it. But I just want to repeat that type of indeterminate form isn't such as for me, it's not a really significant thing to discuss, because no more than just to help, it can be used just to help you to understand the basics, but on practice nobody talks about the type of indeterminate form. Like, okay, so first of all let's talk a little about this limit, because my main goal with my webinars is Q&A and to help you with practice, to get some practice with handling of expressions and so on. In power of 2x, limit below x tends to plus infinity. So, first of all, let's discuss a little what do we know about about the terms of this expression. What's the limit, for example, of this thing? Just of simply with one term.
Infinity?
Of course, it's infinity. You know what it tends to infinity, that's nice. This one tends to infinity too. I think we don't need to discuss it. I think it's clear enough. And what's the limit of this guy? Of course, we have 0 as limit. I hope it's clear, and please ask me a question if you don't understand something, if you miss something. So I really want to help you. And what can we say about this term, about this guy? What's the limit of it? Can we say anything about it? So what's the limit? -1 or 1 or both of them? Can we name the concrete limit of this expression? Yes, of course. There is no limit of this expression, because we know that sometimes some expressions have no limit, and that's nice, that's normal. So with some functions or some sequences have no limit. So, for example, this thing is somewhere, it's a bounded thing, somewhere between -1 and 1. I think that you understand what I mean. So what can we say about the whole expression? We know that we have 2 plus and infinities, like 0 is something bounded. So it's easy to say that the whole value, the whole limit of this expression in the salitel is infinity. The same analysis can be provided in the denominator. So for example, it tends to infinity. Also, it looks terrible. This guy tends to infinity, and this guy tends to 0. He's not interesting here. So the whole value of the denominator is infinity. So one can say that we have indeterminacy in the form of infinity over infinity. Okay? Well, nice. And what can be our next move if we want to compute such limit? Like we understood that that's a limit of the form infinity over infinity. Like we have some common special practice that we do when we talk about such, but usually we do when we talk about such limits. For example, as you can see, when we have indeterminacy of a form 1 in the power of infinity, we like to recall, to remember the second significant limit and to apply it somehow to get an answer. What do we like to do when we have a limit infinity over infinity? Usually we provide to use technique that's called, like in Russia it's called in this, for example, in this book, it's called how to say, командира вперед. I don't know how to pronounce it correctly in English because all my translations sound disgusting for me, as I don't know. But the chief must be on the first line sounds really terrible, for example. But in Russia it sounds like командира вперед. That means that the most important guy must be in the first line. That means that always in the when we talk about such expressions, we try to find the most important term, the strongest one. As I understand, as I remember, you know something about hierarchy of functions, like you know the rules of comparison between polynomial, exponential, and logarithmic functions. Okay, that's a clear thing. I don't need to pronounce it. Or do you need any words about comparison of such functions? Do we want to talk about it? Pluses, minuses? Who gets there faster? Yes, for example. Who gets there faster? Plus, that means that we need to talk about it. I hope I understand. Okay, so maybe we will just use the same book. Like, look, I suggest you to know several important examples. Here you can find them. If you don't speak Russian, you can just remember that here you can find them. But we have some knowledge about hierarchy of functions. For example, some rules that we need to know, and sometimes we apply them to compute the limits when we want to compare who is the fastest, who is the most important. Like, you should know the following thing, like logarithmic function is really opposite to fast is really slow. Ooh. Such a complicated word, it's impossible. Like, you know, but logarithmic function is really small. That means that when you divide it over some polynomial function on exponential function, you will always have a limit like 0. So we can write it in the following form, for example, in the most common form, like logarithm. Any power of logarithm is slower than any power of polynomial. Mhm. So I'm also interested if you if this style is convenient for you. If x tends to infinity, when for every possible k and for every possible positive c, you will have this value of limit. Even if you will have, I don't know, let's make some example, like you have this power of logarithm and you have this power of x. Okay? That means that informally, that means that logarithm is really slow function and it's asymptotically slower than polynomial one. Okay? I hope it's okay. The same thing can be said about the polynomial function or polynomial-like functions when you compare them with exponential functions. I want to say the following thing, that if you have limit of this form, when exponential function always win the battle with polynomial function. For example, the same thing, I don't want to use minus. If you'll have something like this, the value of limit will be 0. It will be still 0. So informally, that means that logarithm function can be asymptotically worse, slower than polynomial one, and it's slower than exponential one. So that's what you should know about the hierarchy of functions, about the speed. Okay, I hope maybe that was a clear material, but maybe somebody will find it useful. Okay, so let's turn back to our expression. How do we want to evaluate it? How do we want to work with it? How do we want to compute it? Like here, you can we have a following common idea, as I've already said, but we want to find the smartest, the fastest guy in the skeletal and in the denominator. So who is the fastest guy in the skeletal? What can you say? Who tends to infinity and who is winning in our hierarchy? Who is the top guy? Which term is the fastest among all of them? Of course, we know that the smartest guy, the guy with highest speed is exponential function. And what can we say about the denominator? But it's easy to see that we have the same story and we know that the fastest guy is e in the power of 2x. So we like, in such situations, we like to divide the skeletal and the denominator. We can factor out the common multiplier, for example, and we can write it in the following form. We like to write it in the following form. Oh, sorry, one minute. It will take. It will take some time to write it. So, what was the goal? Why did we decide to do it? It helped us, first of all, to kill with common multipliers, prove them out. And what can we say about the skeletal and the denominator now? What can we say about the limit of skeletal in this form? what can be said? Dear colleagues, yes, with correct answer, but I just want to understand if auditory understands what's the limit of this expression. Who understands the limit of this expression? What's the limit of this expression? So plus, minus, something like this. I just really need your commentaries. So if I pause, so it means that I invite you to write plus and minus. So let know about each other. Okay, at least 3 people understand, as I see, as I believe. So we understand that the limit of the skeletal is 3 and of the denominator is -4, and so we can easily name the value of limit. So why it happened? Why everything is so simple? First of all, because we know when we divided all the expressions over the fastest guy, so all other guys turn to be infinitely small. We know that this expression tends to 0, just because polynomial is slower than exponential. And this guy tends to 0, just because he was small and now he is even smaller. And this guy, he was bounded, but now we divided it over something infinitely huge, infinitely big. That means that bounded over big is a small. That's okay. So the only thing that is what's important here is 3, and the same story with -4 in the denominator. So that's why we have using the rule of limits, of arithmetic of limits, that if something tends to 3 to constant in the skeletal and something in the denominator, when the value of the whole expression, the limit of the whole expression, is a fraction of limits of skeletal and denominator. We can easily say that the whole limit is -3/4, and that's nice. Okay, I hope that we figured out this example. Okay, we don't need any commentaries now, any extra comments. Silence, such a silence.
Hello, could I have a question? One question,
Of
one
course.
small question. In our example, if we would have a degree, the whole statement, what kind of form
Like
it would be?
you want to discuss, for example, where example you write in the chat, like.
Okay, maybe this one.
For example, like look, as I've already said, the idea of type of indeterminacy is a kind of specific form, is a kind of specific question. As for me, like my logic is to say that it's most intuitive way, like it's in the power of n. Most intuitive way is to say that we have something huge in the power of huge in the skeletal, and the same his story in the denominator, so we have infinity over infinity. But you can, or even more natural ways to say that it's easy to see that this thing, what's the limit of this thing. So it's easy to see that we have no indeterminacy, as for me, because you can see that we have a concrete number which is not 1 in the power of n. So if your number isn't 1 and it's in the power of n, so you can always name the limit. If your number is smaller than 1, so the limit is 0. If your number is higher than 1, is above 1, so the limit of this expression is infinity. But if we want to pronounce it, to find some, to look on this expression like on something that has indeterminate form, indeterminate form, I'll prefer to say that we have infinity over infinity, because formally you can say that but you can easily rewrite it in the power in this form. So that's why I answered this way on your question in chat. And it's really natural to say that we have infinity over infinity. So maybe, to be honest, I'm not the author of this course, as maybe you know. I want, one second please, somebody wants to join us. I'm not the author of this course, and I don't find this part of this of course is really significant, like the way to how to distinguish types of indeterminacy. It's more natural in your question in chat to say that we have a number in the power of infinity, so it's an easy thing. Maybe my answer isn't really good, but maybe if you're really interested, I'll think a little more about it later. Or I can answer the author of the course, what does he mean.
So we have different types in this case, yes? Formally.
Formally, we don't talk about times of indeterminacy. It's because it's not really because you understand that this thing depends on your on simple arithmetical operations. It's not interesting to talk about it because you can see that formally here we have if we stop on this form, just on this form, we have infinity over infinity in the power of infinity. So formally you can say that it's some really specific type of indeterminacy, because you can't say what's the limit of such expression if you have such expression. But you doing simple arithmetical operation like opening the brackets with brackets of power, you can get some well-known form, like some much more standard form, infinity over infinity. So formally we don't talk formally about terms types of indeterminacy. That's my answer. Okay. If we stopped with discussion, when I want to return a little back to this book, it's a really good book. So if you want to learn how to compute the limits, it can be extremely useful for you. But to be honest, it has more material even you need. Yes, I will send you plenty of books and plenty of links, especially if you're interested in materials in the Russian language. As I understand, the majority of students are Russian talking, so it will be useful for them to work with it. Am I right? I think I'm right. Okay, so let's turn back. So, but what's the difference? I want to turn back to the question of difference between function and sequence. So we've figured out the limit. We found the limit of this expression. But you know that here we have the same function, but maybe something will change. Maybe something will look a bit something will change. What can you say about this expression? First of all, my first question: if x tends to minus infinity, what can you say about who is the fastest guy in the skeleton? Who is the fastest guy? Yes, the third one. You're quite right. He's right now. It's a bit. It can be a little confusing thing, but we know that minus in the power it makes your exponent smaller. But because our intuition, our feeling of beauty, always works with positives, but real life has a deal with negatives too. So we need to understand that when x tends to minus infinity, when minus 3 over x is a positive number. So here we can find e in a huge degree, in a huge power. So what means when we use this guy tends to infinity, because we have e in the power of in positive power. And here we can see something really small, because here we can find e in the power of minus infinity. It means that we have 1 over e in the power of infinity. So we have something really small. And so we can find the huge difference between this example and this example. So because now the fastest guy is this one, here you can find that the fastest guy is this one. So and as usual, the real value of limit of type of infinity over infinity is just the fraction from the coefficients before the fastest guys, like minus 1 over minus 3. And so it's a real answer for this limit of this real value of this limit. Minus 1 over minus 3, so 1 over 3. That's the value of this limit. We can repeat the same actions like we have done here. We can just divide it over e in the power of minus 3x, and you will have and you'll get minus 1 over minus 3. So also functions, but so also it's possible that the limit of your function, where the point of limit isn't infinity. For example, you can face these functions that has really different values of limit. But one of my favorite examples is a set of examples like 4.6, 4.7, 4.8. What can you, for example, what can you say about the limit of 4.8? What can you say about it? So how to compute it? Here we can see some fraction, and x tends to infinity. So maybe. So first of all, please write plus and minus if you understand what to do. If you have any ideas what to do with such expression, it's really significant for me, because I want to estimate where. Please. I'm talking about 2.6, 4.6, this one. X tends to infinity. So, okay, at least I saw some pluses, but that makes my heart warm. Okay, so as you can see, we can easily divide it over x and square over x and square. So the value of this expression will be 3 over 2. So that's nice. And what happens here, for example? As you can see, now we have a finite point of limit. So no infinity, but 1. So why does this limit is significant, is interesting? What can you say? Can we substitute x for 1, just to place 1 on the place 1 instead of x in this expression? Yes, I'm ready to discuss the problem with its root. Yes, you can easily see that we have root, that 1 is a root of cell and root of the denominator. That means that we need a specific analysis if we want to talk about it. So I'll try to do it as fast as possible. So just to show you the technique what to do in such situations. X plus 2 to x squared plus 3x minus 5. Look, if you have a limit of the form like polynomial or polynomial, first of all you can try to substitute x for 1. Unfortunately, in this case we'll get something like 0 over 0, because 1 is a root of serial and of denominator. But what can you say? You have a well-known from the school years formula that if you have quadratic function, when you can rewrite it in the following form, where x1 and x2 are the roots of your expression. So you know that 1 is the root of the serial, so you know that the first term will look like this. The same thing will happen with the denominator. You know what you'll have like x minus 2 over multiplied on x minus x3 something. First of all, do you have any ideas how to find this strange x2 and x3 in a short time? Okay, let's not waste our time, but you can easily find that if you will if you want to get, we know that this expression equals to this expression. Yes, you're quite right. So if you will compute the term without x, here the only term without x is 3 over multiplied on minus 1 multiplied on minus x2. So you can easily find that it must be equal to 2. So it gives us an understanding that this number x2 is 2 over 3, and the same knowledge about this thing, but here we can find plus 5 over 2. Why is it significant? Because now we can easily say that we can throw out x minus 1 here, we can throw out x minus 1 here, and we can get an expression such that we can easily compute the limit of it. Like we can return 2 here, and we can easily compute the value of the limit 1 over 7. I hope I'm right, because I can make a computational error. So you can see that the limit of function is really flexible thing. It's a really flexible task. It can change significantly, depends on the point of limit, and you have no such problem with sequence, because when you talk about sequences, your point of limit is always infinity. The third case is 4.8. It's really funny. It's not a complicated thing. I'll answer in a moment. Okay, but that's not that's like a joke, because you will find no problem with substituting x for 2 here. So you can easily compute the value of serial. It's the same like that x equals to 2. And here, the same story, you can just compute 2 numbers and the fraction will be the answer. Okay, we have a question like why can we just remove x minus 1 in the expression if the expression isn't valid when x equals to 1? Look, when we talk about limits, like when we talk about the situations like x tends to 1, that means that we want to look what happens when we use axis really small, really close to 1, but we never use the 1. You can evaluate, well, you can compute this expression using x like, for example. Is it possible? Yes, it's possible, because it has some value, it has some meaning. This expression has some meaning. You can, when we talk about the limits, we like trying to make your number is really close to 1, to the point of limit. But we never use this point. So that's why we can easily remove x minus 1. Because that's a number. That's not a 0. That's a non-zero number. So nice if it helped you. Okay, it looks like we spent an hour together, and so it looks like it's time to finish our webinar. I hope it was useful for you in some cases, in some doubt. So I suggest you to collect new questions for this. To collect your questions before the following webinar. When representative of level of course. Yes, it gives you a kind of good estimation of the level of course. So it's, if you have an experience in calculus, it can be easy enough to you. So yes, it can be. So I suggest you to collect your questions before the second webinar, or you can ask me in chat, or you can and don't forget, we have a special assistant who works here just to answer your questions, because my job is to work with some complicated things and to provide webinars, and assistance is just for the questions. He's always ready to help you. Maybe he is more successful guy in answering than me, because I'm a bit kind of busy guy. So it was nice to see you. I think it's time to finish. So thank you and goodbye. See you next week.